The U.S.-Taiwan Cooperation Project of Megaports initiated at Kaohsiung Port in order to prevent terrorists from using containers for illicitly trafficking in nuclear and other radioactive material. The National Nuclear Security Administration of the U.S. Department of Energy launched the Megaports Initiative, a second line of defense program at major ports around the world in an attempt to promote international cooperation to detect, deter, and interdict nuclear and other radioactive material via container smuggling. Proliferation of illicit trafficking through maritime shipping could potentially endanger world security. The Memorandum of Understanding (MOU) between the American Institute in Taiwan (AIT) and the Taipei Economic and Cultural Representative Office (TECRO) in the United States, concerning cooperation to prevent the illicit trafficking in nuclear and other radioactive material, was signed on May 25, 2006 in Washington, D.C. The U.S. has spent approximately 2 billion NTD to install the most advanced radiation detection equipment, including 38 radiation portal monitors (RPMs) and 2 spectroscopic portal monitors (SPMs) at the port of Kaohsiung. Upon equipment installation and system operation, the U.S. also provided 3 years of maintenance support and training.
All the equipment and maintenance responsibilities have been officially turned over to Taiwan Customs effective October 1st, 2013.
The radiation detection equipment at Kaohsiung includes 1. Radiation portal monitor (RPM) and optical character recognition (OCR). 2. Wireless communications equipment. 3. Central Alarm Station (CAS). 4. Handheld radiation detection equipment, including personal radiation detector (PRD), survey meter, thermal RIID, and ORTEC. Images retrieved from RPM cameras as well as alarms indicating the presence of gamma and neutron rays are transmitted back to CAS via Transmission Control Protocol Internet Protocol (TCP/IP) of wireless communications equipment. Due to the vast size of Kaohsiung's port, radiation detection equipment was installed in 2 phases. 1. The construction and installation of Phase 1 took more than 3 years. Upon signing of the MOU, the U.S. delegation conducted site surveys, provided design concepts and construction assistance, helped install equipment, conducted system-level acceptance testing, and provided training. 23 RPMs, hardware equipment, and CAS were installed at Terminals 2, 3, and 5, and became operational on September 19, 2009. 24 CAS operators on 3 shifts of 24 hours have been recruited to operate the system. 2. The site survey for Phase 2 was conducted in November 2009. 15 RPMs and 2 SPMs were installed, and the system has been operational since October 2010. 1. RPM detection. All import, transit, and export containers have to go through RPM lanes. Whether or not an alarm sounds, all vehicles continue to pass through the lanes and arrive at the yard container stacking area to unload containers. 2. Alarm and OCR. When the radioactive material inside the container is detected, RPM will generate an alarm and simultaneously activate a CCD electronic camera to obtain the container's number. After OCR recognition, the image will be transmitted back to CAS via wireless communications equipment. 3. Analysis process in CAS. Once receiving the alarm signal, CAS operators will soon conduct the inspection procedure, verifying if RPM image and container information conform to manifest and import-export declaration forms to determine if a secondary inspection is required. 4. Secondary inspection procedure. After analyzing all information and decided to conduct a secondary inspection, CAS operators will coordinate with shipping company to relocate the container to the appropriate area for further inspection. The secondary inspection team will carry handheld equipment to the site to conduct secondary inspection. After the container number is verified, PRD and survey meter are used respectively to identify the spot where the highest count rate is located. The spot is marked with tape or marker. The high reliability thermal RIID is then used to identify any isotopes, and its energy spectrum record is then saved. Another isotope identifier, or tag, is then placed at the marked spot where the highest energy level was detected. To identify found and suspect isotopes, its energy spectrum is also saved accordingly. 5. SPM detection and X-ray scanning. After the completion of Phase 2, containers can be redirected to CY74 and CY122 for secondary inspection and X-ray scanning if an alarm is generated after RPM pass.
Hence, a complete and non-intrusive inspection can be realized.
6. Follow-up.
After the secondary inspection, CAS operators will go to SWS to download the energy spectrum and then transmit the data back to CAS.
CAS operators will review the data from SWS or from SPM. Containers will be released if the alarm requires no further investigation. If further investigation is necessary, the container will be detained at the restricted area. Meanwhile, Atomic Energy Council will be notified to assist with further investigation as appropriate. Taiwan's participation in Megaports initiative has already yielded positive results since its implementation. 1.
7 cases of high-dose radiation sources concealed in imported goods were detected, including industrial sources in scrap metal cabinets, industrial neutron sources in imported and exported scrap aluminum cabinets, imported industrial sources contaminating the entire container, and scrap metal cabinet contaminated by radium and thorium.
2. From March 11, 2011, when Japan's Fukushima nuclear disaster occurred, to August 2013, 226 contaminated containers were detected in Kaohsiung port. The Atomic Energy Council was notified accordingly to assist in further investigation or to endorse returning the containers to their original ports. Since beginning operation of the radiation detection system, we have successfully prevented the proliferation of contaminated radioactive material in Taiwan and have consequently maintained food safety for the general public.
In addition, radioactive steel and radioactive housing are avoided, contributing to the public health.
We are proud to announce that illicit radioactive material is always detected and found at the port of Kaohsiung after the U.S.-Taiwan cooperation project of Megaports initiated became operational. Future prospects. The operation of Megaports initiative has been smooth and effective.
Currently, Kaohsiung Port houses 38 RPMs, 2 SPMs, marking Kaohsiung as one of the biggest radiation detection systems in Asia. The third largest installation in terms of volume and quantity of equipment, and the system with the most extensive wireless communications equipment.
Hence, the anti-terrorism task can be fully realized here. The implementation of Megaports also complies with the U.S. 100% Container Scanning Act of 2012, helping enhance Taiwan's international competitiveness. The transition of radiation detection system to Taiwan Customs also marks a significant milestone for Kaohsiung Customs.
The smooth U.S.-Taiwan international cooperation will help strengthen the harmonious relationship between the U.S. and Taiwan and hope to set a good model for CTPAT, AEO's verification process for excellent manufacturers and other international cooperation projects in the future.